Welcome to Yoke's first ever video demo, where we're going to take a first look at the Yoke CLI and ecosystem. For those of you who don't know what Yoke is a Kubernetes package manager, kind of like Helm or Timoni, with one crucial difference. Instead of deploying charts or queue modules, which is templated YAML or queue configuration, we just use code to deploy, code compiled to WASM. If we deploy our first package, we just say yoke, takeoff, or apply, the release name, and the WASM module. We can configure standard input, but that's all we need to do. And from there, Yoke will deploy the resources generated by executing your WASM module. So we're going to give a first demo of that today. Let's take a look. What we're going to be doing is following along with the kind Ingress documentation. With kind, we're going to be able to create our own local cluster and install Ingress to it and create our own applications. We're going to be using option 2, extra port mapping, setting up a kind cluster that maps the host port 80 to the container port 80, letting us talk to our local cluster over localhost. We're going to be using the YAML defined by the kind project to deploy the Ingress and Nginx controllers. Then, this is their YAML that they use to define an application. We're going to be turning this logic into a Yoke application that we're going to define in code. Here they have a pod, a service, and later an Ingress. And we're going to use that concept to build our application. Though we're going to use a deployment instead of a pod, but that's all right. This example lives in the Yoke CD examples repository. You can see the README for more information, and there's a run.sh for easily doing the setup and then playing around with it. So let's take a look at that. Here we have the run.sh. What it does is it installs Yoke at its latest version, creates that kind cluster named demo ingress, maps container port to host port 80, then it applies that Ingress and Nginx YAML from the kind project, but it uses Yoke instead of kubectl. This just allows us to create a Yoke release with that YAML instead of having it unmanaged with kubectl. Then it prints out some instructions for compiling to WASM using the Go command line. The code is going to be written in Go. We'll talk about that in a second. And then how to use Yoke to apply some release with that WASM and some input to your cluster. And we can see that I ran it over here where it created the cluster, deployed the Ingress and Nginx using Yoke, and then printed some instructions that we'll use in a second. So as we said, the code is written in Go for the tight integration with the Kubernetes ecosystem and because it compiles well to WASM. What's interesting is that we have the normal standard library packages like JSON, FMT, like JSON, FUMT, IOOS, but we also have the core Kubernetes packages, apps v1, core v1, networking v1, meta v1, and such, which really allows us to use the native Kubernetes types to define our application. We have an entry point called main, which just runs the core logic, and if there's an error, writes it to standard error, and then exits with a non-zero exit code. The configuration for our application is defined here in this struct, where we have the name of the release, the image that we want to deploy, the command, the path prefix for our Nginx configuration, and any environment variables that we want on our deployment. We have the configuration defined here with some defaults. We use the YAML package from API Machinery to decode standard into our configuration structure. We declare some labels that we're going to be using throughout our resources, and we declare a deployment. We have all of this strongly typed, the kind, the API version, and the specification. If I want to discover, more fields, I can go in here with my IntelliSense, and I can figure out a strategy, hit more values, complete this, and continue building my application, as well as having access to the documentation for all of this. So let's remove this for now. Here's our template. We build our pod spec. We're passing in our variables from our configuration. So the image, the command, the environment variable. Here we're using our map that we defined as our environment variable, our map of string to string, and we're using this function to construct it into an array of core v1 and vars. This is the advantage that we get with Yoke, is that we have normal control flow processing to build our application, which is great. Next, we have our service that we're defining using the same selector that we defined above with our labels, defining some ports. We're mapping port 80 to 80, and we're calling this HTTP. Next, we have our ingress, which we've defined as an immediately invoked function expression. So if the config.path prefix is empty, we'll return nil, and there is no ingress. Otherwise, we return a fully functioning networking v1 ingress structure. And we can see we have the rules, the ingress rule value, HTTP paths, where we have a path type of path type prefix, the configuration path prefix that we set, and we map that to the backend, which is our service, using the service variable's name. And voila. And as we said before, a Yoke package is just about turning standard in into standard out. So we encode those resources back out over standard out, encoding our deployment, our service, and our ingress. In fact, it's just a normal program. So if I just go run this.demos ingress flight, need to close the standard input, and voila, we just get the resources as JSON. We can prettify this with with YQ, and this looks like any normal YAML you might have written, except that we have all the benefits of strong typing and code constructs to build our application's logic. Right. So let's go back to this. Let's build our WASM using the Go toolchain. We now have a demo.wasm file from that Go program that we just saw. Next, we can deploy an application. Let's just test our Nginx server first. If we do curl localhost, we see that we get the 404 not found from the Nginx controller. That's great. So now let's deploy an application, which is just having Yoke apply a release called foo that will wait for 2 minutes to get ready, using this demo.wasm and inputting some values. We're going to be using an echo server so that we can see the requests that we're sending. We're going to be serving it over /foo, and these are just some environment variables so that it doesn't leak my environment. So let's apply. So now if we say Yoke inspect, we'll see that we now have two releases, the original Ingress Nginx, but now we also have foo. If we look at foo, we see that we have one revision that has 3 resources built from the local file demo.wasm that has this SHA, this checksum, that was created and active at this time. If we look at revision 1, we can now see all of the YAML that we deployed. So that's a good way of inspecting what we deployed. Next, if we say curl localhost, we still get that 404. If we say curl localhost example, we still get that 404. But now if we call foo, we reach our echo server. So we got foo, we can get foo bar. If we go for bar, that doesn't work. If we wanted to do bar, we could deploy a new thing. So instead of foo, we'll use bar. So this is going to be the bar release with the path prefix bar, and we'll apply that. So now we have a successful takeoff of bar, and if I curl localhost bar, I now hit my echo server. If I look at my inspection, I see that we have a foo and a bar release. That's great. Now suppose that I want foo to not be on /foo, but to be on /example. I can save this, create a new revision. If we look at foo, we now see that we have two revisions, where 2 is the current, using the same file, the same demo.wasm. If we look at 2 versus 1, we'll see that the only thing that changed was this path example instead of foo. Hence, if we say curl localhost foo, we now get that 404, but if we say example foo, we've hit our echo server again. And voila, we've deployed our application using Yoke. Thanks so much. See you next time.